So next up, we're going to be having Margaret Carruthers, who is a science writer here at Space Telescope Science Institute. She's going to talk about the incredibly detailed descriptions of the James Webb first images. They're referred to as alt text or alternative text. Okay, let's see. So those made pretty big news when they first came out. There was articles on NPR, Washington Post, and just all over the internet. Like lots of people were talking about these alt texts, and it was really exciting. So Margaret is one of the writers who worked on those image descriptions, and she'll be sharing her process and how she goes about writing those images for the James Webb Telescope. So there you go. Thank you.
Okay, this is working okay? Everyone can hear me? Okay, so thank you, Jen, and welcome to the students who just came in. I'm Margaret Carruthers. I'm a science writer here at Space Telescope, and as Jen said, I'm going to be talking about the text descriptions that we developed for the first images and spectra that came out from the Webb Space Telescope last July. I'm going to talk a bit about a tiny bit about the telescope for those of you who are not familiar with it, a bit about the images and the whole news package we created. I'll talk about how we went about developing those text descriptions, and give you some samples, and then I'll share some of our top tips or things we learned along the way in doing this. Also, I want to say that this is the first time that I have been aware of presenting to a group who is not able to see not everybody can see the slides that I'm presenting. I am going to try to be aware of that and try to remember to describe the slides adequately. Many apologies if I don't. Please raise your hand if you're like, hey, what was that? But I'm gonna do my best here, but this is a new thing for me. All right. So our first slide actually is the intro slide, and there's a beautiful picture of the Carina Nebula where stars are forming. And just the name of the talk, Illuminating the Universe with Accessible Text Descriptions. Okay, so for those who weren't here for Mark Postman's intro, here at the Space Telescope Science Institute, we deal with telescopes out in space that are looking at space, and they are out in space. And these include the Hubble Space Telescope. So I have a photograph of the Hubble Space Telescope that's orbiting Earth. The James Webb Space Telescope, I have an illustration of that. It's orbiting the sun. And the Roman Space Telescope, an illustration of that. It is still probably in some, I don't know, hangar somewhere. It's being built. Anyway, and a photograph of the people here at Space Telescope Science Institute, a photograph of people celebrating in front of the building after the day the images were released. So we manage the telescopes, and in our Office of Public Outreach, we tell everybody about all the discoveries. As Mark let you all know before, so we have 4 strategic goals, and I'm going to focus on the third one, which is making the world's astronomical information accessible to all. Now, that means a lot of things. As a science writer, it means taking a complex concept and explaining it such that somebody who does not have expertise in that can understand it, right? Because we all have the capacity to understand this information. We just don't all have the prior knowledge that's needed, right? It also means distributing that information. So not just, we have information, but we have to get it out there. So in the past, it was a lot by print or meeting people face to face. And we still do the face to face, and we still do some print. But it also now we can distribute things online, and we can really reach a huge number of people that way. But increasingly, the accessibility also means reaching even broader audiences who had, in many cases, been neglected in the past, including those who've been visually impaired or otherwise lack access to the visuals that we have. Maybe that might be a technical problem or a physical barrier. Okay, so let me just go back a little bit, sorry. In the Office of Public Outreach, so we've got about 50 science communication specialists of all realms, okay? So we've got science writers. I'm just one of 7 or 8 science writers here. We've got graphic designers, some of whom are here in the audience, and who did, anyway. And we've got education specialists. We've got astronomers. We've got software developers, curators, motion designers, animators, a whole wide variety of people, and they all contribute to this, making this astronomy accessible. Okay, so the James Webb Space Telescope, what I have here is a illustration of the Webb Space Telescope, and also an illustration kind of describing, just a drawing illustrating the variety of science that Webb was designed to do. Webb is out there 1 million miles from Earth. It's orbiting the sun with Earth, and it's looking out. It's looking out at the deepest, farthest galaxies that have been seen before. It is trying to find out how these galaxies formed. It is looking at galaxies that are crashing together and interacting with each other to see how they evolve over time, okay? It's looking at stars that are just forming, little baby stars, and stars that are dying. Maybe they're just, slowly or maybe exploding, and then creating the dust and gas to build new stars, right? And then it's also looking at planets. It's not looking at Earth. It's not looking at some of the planets toward the sun, but it is looking at some of the planets in our solar system, like Mars and Jupiter. And it's also looking at planets way, way, way far away, orbiting other stars. Okay, these are called exoplanets. So Webb is doing a whole lot of stuff. Astronomers are super excited, as they should be. We are excited to tell you all about it. All right. Sorry. Okay, so Webb launched in December 2021, and it spent about 6 months. We spent about 6 months, controlled here, by the way, at Space Telescope. Okay, there's people upstairs telling you what to do. Spent about 6 months getting ready to collect the data, to start doing science. And on July 12th, last July, we were finally ready to reveal this first data to the public and also to the astronomy community. They were kind of in the dark about it as well, most of them. So July 12th, we released, it was a set of 6 articles about 5 different targets that Webb looked at. These were designed, these observations and this information, this outreach is intended to show the variety of science that Webb can do, all the exciting things to get people so that people understand everything that Webb is doing and that Webb is working well. And fortunately, it did not disappoint. There's a whole lot of other things you can hear about that, about how it's just exceeding all expectations. But I'm really here to talk to you about the news package and how we get that information out. So what we have on the screen here are 6 screenshots of the sort of headlines and images of those first the first images and spectra. We had an overview article with the illustration. We had an article about galaxies colliding and black holes in those galaxies. We have one about a dying star called the Southern Ring Nebula. We have one about a field of galaxies, thousands of galaxies, very distant, a star-forming region where new stars are, baby stars, and an atmosphere of a distant planet. And you'll see too that some of these are most of these first images are images, they're photographs, okay? But we also had what's called spectra. And spectra are, if you take light and you spread it out, you can see all the separate colors there. So invisible light, you can see the rainbow. In this case, we're talking about invisible colors, but a spectrum allows astronomers to look at the brightness patterns of different colors, which tells them something about what that thing is made of and other properties. All right. So what did this news package consist of? Again, this is getting this information out, trying to make it accessible. We're not like hoarding all the information. Our news package had, what we have on the screen here, by the way, is, sorry, was our 4 screenshots. One of the kind of homepage for the for an article about the Carina Nebula, the cosmic cliffs of Carina, where the star-forming region. We've got a screenshot of the article that was written about it, a screenshot of the caption to one of the images, and a screenshot of a social media post. So our news package had images, spectra, those graphs that I was telling you about, articles, like in-depth articles about what is this, what did Webb see, what is it going to tell us about, how did it look at it, and then a caption of the image going into more detail about what's there, and then social media part of that too, to get everybody excited very quickly and they can come find out more information. All right. Now, there's one extra component here that we have for the first images, and that was this alt text or alternative text descriptions of the images. The images and spectra are a really important component of communicating the science, communicating the wonder, the excitement of the Webb Space Telescope, okay? But if you can't access those images for whatever reason, it's not fair, right? And we want to make sure that people can really get the most out of this information. So these, in addition to all the article content captions, we wrote descriptions of the images, okay? So what I have on the screen here is another screenshot of the image of the Carina Nebula, a longish description of alt text, which I won't read, I'm just letting you know that it's there. An image description that comes up on social media. On Twitter, now we have image descriptions. And then a description from our thumbnail image, and that's just to show you that we do write different types of descriptions depending on the purpose. Okay, in addition to, so alt text is, it's a description, you kind of like code it into a field. I'm sorry, developer people, I'm not saying it right, but you put it into a field, okay. And usually there's a limit on that, like a character limit. You can only put so much information in there. But sometimes we need more information. So we also wrote extended descriptions because some of our images, our graphics are complicated. What I have here on the screen are 2 graphics that are more complicated. There's one that shows a kind of a sliver of an image of lots of galaxies, and then a pullout of one of those galaxies so you can see it up close, and then a graph that shows the different elements that are in that galaxy, which is crazy that we can see that, and it's 13.1. That's light that was given off 13.1 billion years ago. If you can, yes, exactly. That's what we all felt. Yes. Anyway, and this is a pretty complex graphic, so we have a long description here, all right? Another graphic we have over here, and I'll go into more detail on that one, it's a what we call a transmission spectrum. It's basically a graph showing the brightness of light of different wavelengths, and it shows what different molecules are in this planet's atmosphere. And we needed a long description of that one, okay? So we did lots of things to make these accessible and interesting at different levels, right? Great, okay. So I'm going to talk a little bit about the process we went through to develop the text descriptions and the approach. This is not a new thing, having alt text. I don't know how long it's been around. Somebody probably does, I don't know. But we've always had this, and we have it in our system, in our websites. It's a requirement. You can't publish an image without it, okay? However, the way we're approaching it is different. At one time, we had a very limited character count, like maybe 60 characters or 120, okay? That's like less than an old tweet, right? Are we okay?
Oh, yeah, this microphone.
Oh, sorry, I'm echoing. Okay. It's not enough, right? You can say, oh, pretty picture, and that's pretty much all you can say, right? It's not enough. The other thing was we wanted to make this part of our process, not sort of an afterthought. A lot of times alt text is an afterthought, or it had been, right? Oh, I got to fill this in. So we really wanted to make these descriptions great because we wanted to share this excitement and these beautiful images and spectra. So we did a lot of practicing, experimentation. We worked with existing imagery from Hubble and graphics that we worked on, and we did a lot of writing. We did a lot of reviewing of each other's writing. We worked with consultants from the blind and visually impaired community who provide a lot of really important feedback. You know, one time we met with them and I read aloud a description I wrote. I was like, what do you think? Does this work? And they were able to provide feedback like, yes, I can imagine that. No, that makes no sense. Please go back. And that's really important. We adjusted our technical constraints, okay? What we did is, what I mean by that is we increased the amount of space we'd have for that alt text field to 1,000 characters or so. That's pretty good. You know, that's a pretty good number. And thank you to the people who did that. And we began developing standard styles and guidelines to make it easier for us, because a lot of times writing this stuff, it's about making choices, and you spend a lot, should I do it this way? Should I do it this way? We make the choice, we figure out how to do it, and then you can kind of focus on the content. Approach. Again, rather than doing the alt text and descriptions later, we made this is part of the news package now. It is part of our writing. It's, you know, we have our article, our caption, our social media, our alt text. It's part of the whole thing. And we think, and really, I do want to, you know, we're focusing on the audience needs, you know, rather than just being like, oh, I checked that off. I wrote an X in that field and now it's done. And we weren't doing that before, but I'm just saying that does happen. You might come across things like that in other alt texts, not ours. And we put the alt text, the descriptions through a full editorial process. This is another important thing, especially when you're talking about science and technology imagery, okay? You know, if you're talking about kind of everyday photos, picture of a dog playing with a ball, that's pretty, you know, that's pretty standard, right? But with some of these images and the graphics, they're not familiar, right? They're not familiar. They show crazy stuff. They're complex. We had to research. We had to draft. These went through subject matter experts, editors, you know, accessibility experts. We have one of our staff members is visually impaired. He reviewed stuff. We make sure it's going through the full editorial process, and that's really important because this, you know, you all are relying on this, right? It needs to be right, it needs to be clear, and we want to treat it like any other science communication, clear and not, and doing its job. Okay. All right. Okay, so I'm just going to share with you a few examples. This one, what we have here, oh, by the way, the previous slide just had text on it, so you weren't missing anything if you couldn't see any pictures, there were none. So this slide, what we have here is on the right, I'm just going to read to you what we have from the text, and I have the alt text that was written by one of our writers here, Claire, who is here. Yes, she's here. Now, first of all, I'm going to read this description, and then I would like everyone to listen carefully, and then I'll tell you what. Oh, sorry. Okay, Webb's first deep field, SMACS 0723. That's the title. Thousands of small galaxies appear across this view. Their colors vary. Some are shades of orange, while others are white. Most appear as fuzzy ovals, but a few have distinct spiral arms. In front of the galaxies are several foreground stars. Most appear blue, and the bright stars have diffraction spikes, forming an 8-pointed star shape. There are also many thin orange arcs that curve around the center of the image. So I hope that paints a nice picture in your heads. And I would like, there's 2 people at least, maybe 3 in the audience that are probably familiar with this image because I see them in the middle rows with jackets with this image on their jackets. So you can get images, by the way. You can get jackets with this image. I want to tell you something about this. Claire can describe this beautifully, but she thought a lot about what the purpose of the image was. What is it trying to convey? How does it make you feel? And I do want to give a shout out to her as well because Claire found out at the last minute that this image was going to be unveiled by President Biden. So while she's writing the caption, oh my God, no pressure, okay, here. So I think she did a beautiful job. Okay, second story of alt text development. Okay, this image is the cosmic cliffs of the Carina Nebula. All right. Now, so we were under a tight time constraint, okay? We had a lot to do, and we had to get this stuff ready to be out. July 12th was the day. It wasn't going to change, okay? So I'm meeting with my supervisor, who's hiding in the back here, and I'm like, we have so much to do. He's like, well, how can I help? How can I help? And I was like, okay, well, I got to write this alt text for this image, but it's so beautiful. I don't even know where to start. Like, how can I do this justice? I don't even know what to do. I'm a writer, I'm a science writer, I can explain things, but describing this is, He's like, let me take a shot. So it's like, thank you. So John took a shot. And this is beautiful, what he came up with. We did a little bit of editing, but I'll tell you, it's mostly, and John is a designer. He is not a writer, he's a designer. But he is a writer, he's a great writer, but he doesn't know that. But he's actually a designer. Okay. So, and let me just read this out loud, because this actually got a lot of press too, okay? The image is divided horizontally by an undulating line between a cloudscape forming a nebula along the bottom portion, and a comparatively clear upper portion. Speckled across both portions is a star field showing innumerable stars of many sizes. The smallest of these are small, distant, and faint points of light. The largest appear larger, closer, brighter, and more fully resolved with 8-point diffraction spikes. The upper portion of the image is bluish and has wispy, translucent, cloud-like streaks rising from the nebula below. The orangish cloudy formation in the bottom half varies in density and ranges from translucent to opaque. The stars vary in color, the majority of which have a blue or orange hue. The cloud-like structure of the nebula contains ridges, peaks, and valleys, in appearance very similar to a mountain range. 3 long diffraction spikes from the top right edge of the image suggest the presence of a large star just out of view. So I think that's a beautiful description. I hope you guys do too. Now, the third example I want to give you is of an illustration, and that's okay. And I'm sharing this one. I will describe it in a second. I'm sharing this illustration to tell you that writing these descriptions does a lot for the writer. So we do it for the audience, but the writer gets a lot out of it. And what I got out of this one was, this image here shows, it's an illustration that's kind of, it's illustrating the variety of science that Webb can do, okay? And the designer here is Liz Wheatley, and she's in the audience, and it's beautiful. Well, when I first saw it, I was like, that is beautiful, that is gorgeous. I'm gonna have a t-shirt and a bedspread of that. And, but it wasn't until I started describing it that I realized how smart it is, okay? This is not just a pretty image, it is meaningful. So I start writing about it, I'm like, oh my gosh, look at this. She's got, across the middle is a jagged line. That represents a spectrum. She's got color gradation from red on the left to purple on the right, and that's representative of a spectrum too, the rainbow spectrum. In the middle is a hexagonal kind of window almost that represents the hexagons of the hexagonal mirrors of the telescope, all right? And within that hexagon are illustrations of different space objects. We've got a planet, we've got a spiral galaxy, we've got red dots to represent like distant galaxies. We've got something shooting material out. I think that's like a active galactic nucleus or a star. I don't know. But it's exciting, right? And sorry, we've got the 8-pointed diffraction pattern of the stars. So you know, I was like, so I'm writing this. I'm like, oh my gosh, like this is the most awesome illustration of Webb science. It is so smart and it's beautiful. So that, I got a lot out of that. So I just need to share that. All right. So I'm just checking on, okay. What we have here, so images aren't the only thing we did. We did a lot of complex graphics. So on this slide, I've got 5 different complex graphics. I'm not going to go into great detail, except to say that each one contains kind of a combination of images, maps, graphs. They all are very rich in information. They take a while to, you know, they're all accessible in that you can understand them, but they take a while, right, to think about. You have to spend some time with them, all right? So we had to, you know, we needed to write long descriptions of these to make sure, because part of our thing with Webb was getting across the idea that Webb is working well, it's telling us a lot, and it is rigorous, right? We're not just making this stuff up. Like this is some heavy information here. So to do this, I'm going to focus on, sorry, how does this work? I'm going to focus on one of these graphics, which is, this is a transmission spectrum of the hot gas giant exoplanet WASP 96b, okay? What is this? This is basically a graph that's showing us what this atmosphere is made of, or some of the components, and it's basically telling us that there is water in this atmosphere, okay? But the graph has a lot of information on it, and we needed to figure out how to communicate that. One thing to know about alt text for all of these scientists who are thinking about, oh my gosh, how am I going to do this? Is like, it's part of a larger package, right? So your alt text is filling a gap that your article and your caption might not be. So this is just screenshots of the article and screenshot of the caption that go with this image. And those are all easily accessible on a screen reader, okay? So we're filling a gap. What is this graphic giving us that we can't get otherwise? When we did this, again, we're thinking about alt text from the beginning. I was the writer on this. I worked really closely with the subject matter expert on here, Nestor, and we worked on this. He reviewed my work and such so that I understood it completely. But it requires a lot of understanding of the graphical representation, right? You have to know a lot to write this alt text. But you don't have to do it on your own. Here's the short alt text for this, which goes like this. Graphic titled Hot Gas Giant Exoplanet WASP 96b Atmosphere Composition, Nearest Single Object Slitless Spectroscopy. Okay. The graphic shows the transmission spectrum of the hot gas giant exoplanet WASP 96b captured using Webb's Nearest Single Object Slitless Spectroscopy with an illustration of the planet and its star in the background. The data points are plotted on a graph of amount of light blocked in parts per million, yes, versus wavelength of light in microns. A curvy blue line represents a best fit model. 4 prominent peaks visible in the data and model are labeled water, H2O. So that's our basic description there, which I think is probably better than graph, right? But still, if you want to, you can't really do science with this description, right? You can, you're relying on somebody else you're relying on somebody else's interpretation. And it also doesn't really get across some of the depth of the data here. So we, again, did an extended description. I am not going to read this one out loud, but what I will say is what we did was we described the axes very carefully. We told what the range is, what the labels are. We described the data, not point by point, but enough so that the patterns are understandable. We described even the error bars that are on there and how they vary. We described how the model relates to the data. We even gave how many data points there are, which is 141, and et cetera, et cetera. This is a very detailed description. It's intended to communicate that we got a lot of data, and it's really good, and it can tell you a lot. Okay, so you might be thinking, especially if you're a writer or an astronomer, oh my God, that's so much work. How am I gonna fit that in? And the good news is that once you kind of get a structure or a pattern for how you want to describe things, you can replicate that. So what we did was, what I have on the screen here are 4 different graphics. They're all the complex graphics, and I have screenshots of the extended descriptions. Well, we now have very similar graphics that we've been creating for all the new data, all the new news releases. And we basically use the same template. It's almost like a fill in the blank, the x-axis shows this, and the y-axis shows that. Once you get that down, that makes it so much easier, because a lot of the work is just figuring out a good method or good overall framework for describing things, okay? And that's why I have this recycling icon on here as well, because I am big into the reduce, reuse, recycle. And with that in mind, just so you guys know, we have, these screenshots are of when we did this project, these were released as PDFs, accessible PDFs. We now have something called a modal that you click on. I'll show it to you later, but you can click somewhere and you can get the extended description, the alt text. I want to tell you, you can use this, astronomers, you can copy this, fill in the right numbers, so it's obvious that you didn't just copy and paste, right? But this is free to use. It's all public domain, okay? You're not cheating by doing that, right? Okay, so the response. Well, first images and spectra from Webb went all around the world, pretty much everywhere. I think there was more than 20,000 articles. Our spreadsheet broke. Excel wouldn't go that far. So, and this is just what I have on the screen here are a bunch of front pages of newspapers showing the images, and they're all in different, we've got some in English, but some in, German and, I don't know, these other languages, Japanese, and the images of the Carina Nebula and of the Southern Ring and the Stephens Quintet. Okay, so they went all around the world, and this was wonderful. But what was perhaps more exciting, because it was so unexpected, was the response we got about the alt text. We wrote this alt text in extended descriptions because we knew it was important, okay? And we wanted to, and but we didn't really have any concept. I think some of us knew, like, statistically, oh, there's this many people who, could use this. But personally speaking, I don't think I had any real understanding of who was benefiting. And so when these images came out, suddenly Twitter kind of exploded, if that's the Twittery word for it, with, people talking about it. And look at this. This is just lovely. As a blind, okay, so these are screenshots, y'all, of articles and tweets and stuff about the alt text, okay? Like an article from the Washington Post, the unexpected star of NASA's Webb images, the alt text descriptions, see how NASA describes stunning Webb telescope, etc. But the tweets are the ones that really, I think, pretty much got it started in that like sharing this out and connecting us with our audience, right? As a blind person who has had dreams of doing astronomy since I was 6, thank you to whoever not only remembered to write alt text for this, but did so in such a beautiful way. I'll likely never know who you are, but you touched my heart this day, alt text writer. Does that not give you chills? It does for me. And I hope it gives, Claire, this is Claire's alt text here, previewed by POTUS. And, right? And someone else said, if anyone ever tells you alt text isn't important, show them NASA's alt text for the Webb Space Telescope. They are able to convey the wonders and beauty of these in words, making these breathtaking views accessible. Now, if that is not the best, most wonderful feedback, whenever I'm feeling down, I just look at the slide. So anyway, but what I wanted to say about the impact of this, it's not just that it makes us feel good. This had an enormous impact on the way we're doing our work. And what I mean by that is that when this happened, suddenly we were like, we want to do it. We knew it was important. It's not like we were going to stop doing and this was a one-off. This was the beginning of a thing. But suddenly we're like, all of us, oh my gosh, we can imagine our audience. They know they need it. They want it. We're going to write it even better. We're going to make sure everything that we're doing has it. We're going to go back into our archive and even faster get that legacy content done. We have people focused on this. We actually have a summer intern coming in who's going to be working on the Hubble alt text to make that accessible. That's, 33 years worth of stuff, right? So this has had a great impact. I think also it's had an impact on what I hope is that, and I think it's happening, other organizations are seeing it and being like, maybe we should start doing this. I'm feeling left out of the party here, right? It's pretty fun. Okay, so 11:30, okay, great. I'm gonna give you some top tips. Does that sound good? Okay, all right. Okay, so again, we are not, none of us are, I don't have a PhD in accessibility, but I do have a lot of experience on this project. So I'm gonna share, and our writers do too. We were, after this, we worked hard to we worked on a style guide and we worked on, what are some good practices for alt text? What are some ways you can approach it? Because a lot of times it's a little bit intimidating. And I would say that one of the ironic things too is about having done such a good job that got so much press. I think that can also make it feel intimidating to people. Like, how could I ever write something that great? Or how could I do it in this way? So anyway, First of all, you got to think about the purpose of the image, right? Is it there to convey that information, or is it there to just give somebody a visual cue, right? A thumbnail alt text is different from alt text for a detailed giant image, right? Identify your constraints. That's oftentimes how much space you have. Often it's time as well. So you might have technical constraints and others. This is like many other types of writing. So one of the things to remind yourself is people do this every day. They describe visual scenes. Read any book that's not a picture book, right? Listen to the radio, all the radio podcasts, that's all description just using words. So when you think of it like that, that can kind of lift some of the, some of the anxiety off you, right? And then another thing is, simple alt text is better than no alt text, okay? You want it to be accurate, but try not to stress too much if you don't have time or are not sure what to do, okay? Okay, describing images, build a visual scene. Orient the audience, so you can use lots of orientation cues like, to the left, up, down, or geometric things, this, circular shaped region, etc. I find it useful to get the big picture first and then zoom in on the details. If you start with the details, sometimes that's harder to orient because people then have to do that. Okay, how did that fit together in their head separately? Include relevant details, and by that I mean obviously an image has, if you have 1,000 pixels, there's 1,000 pieces of information in there, plus all the relationships. So include relevant details. You don't have to include everything, though. Okay. All right. Science stuff. Connect it to the science, but remember, it's not the same as a caption or an explanation. You do want to use terminology as appropriate, because if you don't, you actually can confuse people. The example I give is if I said, okay, here's a picture and it has a horizontal cylindrical black shape and 4 cylinders descending down vertically from that central cylinder, and you're like, oh my God, what? When I could have just been, it's a picture of a dog, right? So, okay. It's similar in science. You might want to say, you can use terms like, it's a picture of a planetary nebula, and then describe it. So those who know what a planetary nebula looks like can immediately imagine. Or a graph, you use graph terminology. Okay, with any science communication, be careful about misconceptions, and that can be hard. That's one reason why you want other people reviewing your work, right? And also remember, the reader will have other text to refer to, so you don't have to do everything. Okay, if you're stuck, you don't know where to start, ask John, he'll write it for you. Okay. Pretend you're on the phone, and in fact, get on the phone, call up your mom and be like, let me just describe this to you, okay? It works, I have done that. You can pretend that you're describing it to an artist over the phone who has to create the image for you, right? These things work. Don't worry about the length to start. And I mean that by I like to write a lot, and then so I write it all and then I cut back, that's one strategy. Another one that some people say is work well is look with your eyes, not with your brain. And what they mean by that is if you know what something is, you might take shortcuts in explaining something that's shortcuts that aren't useful to the audience, right? So try to take yourself out of the image and describe it. All right, quality assurance. This is an important thing. Okay, so give it to someone who hasn't seen the image. This works really well. In fact, the other day, I sent it to somebody, to our news chief, and she was like, it looks fine, but I fixed, you got left and right mixed up. I do this a lot. I get left and right mixed up. She knew it because she read the description, tried to imagine it in her head, and then looked at it, and she's like, I imagined this. So, okay. By the way, for you all who aren't seeing the screen, what I have are these tips on the screen, and then I just have like a visual kind of describing it, but it's just kind of spot art. So if you listen to the description with a screen reader, if you have that, that can help. Definitely, especially if you are not an expert on that subject matter, have a subject matter expert review it. And here's a big one, okay? When you're writing for new images, wait until your image is almost done, but not quite done. And the reason is this: writing the alt text, we come across errors in the graphics sometimes when we're writing alt text, because you're looking at it with a very careful eye. You might find a proofreading error. You might find a big conceptual problem, actually. Okay, I'm going to go real quick here. Efficiency, make templates, modify existing, make yourself a style guide, that kind of thing. Let's see. Okay, final thing I wanted to say is that, well, first of all, so this is image. I've got James Webb Space Telescope illustration, that same illustration before showing Web Science. And then, just so you know, none of our very talented designers were involved in this kindergarten cut and paste of web images at the upper right. But this accessibility, telescope and many scientific instruments are accessibility tools. A telescope shows us light that is too dim, too far away, too small, things that are too small for anybody, any human eyes to see. Now, Webb and a lot of other telescopes also show us light, forms of light that no human eyes can detect. Webb is detecting infrared light, which is sort of light that's redder than red. Hubble looks at visible and ultraviolet light, which is more purple than purple. And there are lots of other telescopes. So they are collecting and helping us analyze light that no one can see without these tools. So this is just a demonstration here. What I have are 3 different views of the pillars of creation in the Eagle Nebula. One on the left is what our eyes would see in this infrared, which is nothing. And then in the middle is sort of a translation. It's showing some of the light that Webb can detect just in grayscale of one sort of like one color, so to speak. And then on the right is a full color composite image. And that's really, it is part of our work is like making this, translating this into full color images, this invisible light into full color images. And then writing the alt text is one extra step on that road to making this all accessible. So, thank you. I don't have any time for questions, but.
Thank you so much. So we have 10 minutes for a break. And so those of you who need to step out, you can. I was thinking if anyone wants to ask questions during the break. I have an online question. Okay. Let's take 5 minutes to do questions, but also feel free to leave. Okay. What's the question?
Question from Adrian Lucy. I have heard conflicting instructions on whether some modern screen readers still have a character count limit when reading alt text, as well as whether very long alt text is a barrier to quick understanding. Some best practices guides ask for strict caps on character count, often 100 characters. Wow, that's less than a tweet. While others disagree. What was your thought process in navigating this wide range of advice?
Yeah, thanks. That's a really good point. So I can't speak to the technical aspects here, but it is true that previous guidance has been shorter is better. And that is certainly the case in some cases, and it really depends on the context. For something like a thumbnail image where you've got like 50 images on a screen and you're trying to quickly navigate through them, I'm guessing that just like the thumbnail is tiny and it's just giving you an idea of what's there. The alt text is very simple, so we would not have a long extended description. It would just say image of a planet, image of a galaxy, that kind of thing. When you're describing something in detail, I do know that, and Tim can probably speak a little bit more to this, I do know that a lot of people use use their screen readers very fast, so and they can navigate that information very quickly. We also use navigational for the extended descriptions. We use headers and that kind of thing, so you can skip around. We also try, one of the best practices is definitely begin with the overview statement, so you know immediately what this is, and you know, do I want to go into the detail? At least if nothing else, if I only listened for a second, I know what this is, and then I can decide, do I want to go into detail? But I think my personal feeling is if it's not there, it's not accessible at all to anybody. So that's kind of, I don't know if that helps answer the question.
Okay, we have a question in person.
Hi. What changes in your approach?
Your name? Can you say your name,
hi.
please?
Name is Kyle. What changes in your approach for writing alt text for subject matter experts and then to the general public? What are some of the variables that shift in how you write such alt text?
Oh, right. Like if your audience is a subject matter expert. Yeah, I mean, I think it's similar to any other type of content. You can take shortcuts with terminology, certainly. You would want to, depending on the audience, what they're going to use it for, go into more detail. So if it's a scientific paper, for example, and you've got a graph there because you need people to use it, you're going to want to go into detail. Now, one of the things we can do is actually with graphs is provide a CSV file, an Excel file of data. And so some people can then use that in different ways. They can actually, that makes it accessible in other ways, which I am not an expert on that, but some people sonify the data and they can, or can put it on I think a tactile reader. Okay, thank you. Josh is nodding. I think one of the things, the strategies I use is, I try to imagine if my internet went down or I have a low bandwidth, like what would I want to know? What would I need to know to properly access this information? Yeah.
If there are other questions in the room, raise your hand or otherwise indicate you have a question. There's one right over here. There's a microphone.
Thank you. Would you like me to share the way I personally think another good way to write alt text from a blind perspective would be?
Absolutely, that'd be wonderful. Thank you.
No problem. So there are a few steps to this. So before you actually write the caption, just look up a photo and then picture it in your mind with your eyes closed. And then from there, just write the alt text, and it can be confusing with left and right, I know that. But and then just reread it a few times. Does this make sense? Do I need to change it? And so once you get what you want, just read it a few times before actually taking your next steps.
That's really helpful, thank you. And I would actually, on my screen right here, I have thank you, questions, comments, and suggestions. So I would just also encourage anybody, if you ever have any feedback, like we want it. We want to hear what is working, what is not working.
Any other questions, comments, or suggestions from the room? Oh, one over here.
So, what are some problems or some difficulties that like prompted you to make this better, or prompted you to make this?
That is a good question. I mean, I think we just recognized that it wasn't sufficient, that was a big, and this is one part of a big project to make things more accessible, but we realized it just wasn't, we weren't able to convey the imagery and the graphics very well.
Okay, I think there was one more up right here, and then I think we'll have to break.
Before you like fully write down your alt text, like do you ever like write it down on physical paper before you write it online? Because I know with like all kinds of writing, people do that. So I just wanted to ask if you did it.
I think some of us do. Some of us do write. In fact, that is, yes, some of us do write on paper before we write online. Yeah.
And I think we need to take a break, but maybe Margaret can come over here. There were a couple other questions in the front row here too.
Okay,
So let's
yes.
give one more round of applause, or Jen.
Yeah, thank you. Thank you so much.